Hello everyone, welcome. This is WWCode Python. Our mission is to inspire women to excel in technology careers. Our vision is a world where women are representative as technical executives, founders, VCs, board members, and software engineers. Our target are the engineers with 2 or more years of experience looking for support and resources to strengthen their influence and level up in their careers. We do have a code of conduct. We are an inclusive community, and we are dedicated to provide empowering experience for everyone, regardless of their origin, place, and anything else. We do not tolerate harassment of members in any form. Our code of conduct applies to all women code events and online communities. You can read the full version, which is available at this link. So you can go here and read the whole code of conduct. We are a strong community and we are continuously expanding. We have 70 networks in 20 countries, members in 97 plus countries, and 10K plus events. We have $1,025 daily conference tickets and other scholarships. We also have access to jobs and resources and internet connections. Our movement is, as the world changes, we can be connected for. That creates a sense of belonging while the world is being asked to isolate. Today, we have David Beiber, who's a software engineer at Google Brain, and he'll be talking about Python Fire, which is an amazing library, and he is the author himself. And thank you so much, David, for doing this and for your time. I'll pass the mic to David and stop sharing my screen.
Thanks so much. I'll go ahead and share my screen, and we can get started talking about Python Fire. All right, are you able to see my screen and hear me all right? Can you let me know in the chat? Excellent.
Yep.
Then let's get started. My name is David, and we're going to be talking about Python Fire, which is a Python library that I wrote and released in 2017. And what Python Fire does is it allows you to automatically create a command line interface from absolutely any Python program or any Python object. So first, a bit about myself. As Yashika said, I'm a software engineer at Google on the Google Brain research team, where the focus of my research is program synthesis. And since that's about writing software that in turn writes software, I like to represent that with this Escher drawing of 2 hands sketching each other. Also, while working at Google, I helped start an educational program called Tech Day, where each year we bring in between 400 and 800 high school students to Google for a day of classes ranging across a number of STEM subjects taught by Googlers. Before the pandemic began, an unusual hobby of mine was attending city council meetings. And of course, I'm author of Python Fire, and that's what we're going to be learning about today. I'm going to organize the talk in terms of the workflows that Python Fire enables. Python Fire, of course, allows you to create command line interfaces, but it also is a useful tool for everyday development and debugging of Python code. And finally, it's a useful tool for exploring third-party Python projects. And you'll get to see how Fire helps with all those workflows over the course of the talk. So with that, let's start with the main workflow that Fire enables, which is creating command line interfaces. As I said, Fire can take any Python program and any Python object and turn it into a CLI. So we're going to look at the simplest possible program, Hello World, and use Fire to turn that into a CLI. To do so, we take our program and we import Fire, and we add as the main section of our program, fire.firehello. When we run this from the command line, we immediately have a fully featured command line tool. If we run it with no arguments, it will print out hello world, the default value for name. If we run hello at Bieber, it's my Twitter handle, it will print out hello Bieber. Or we can use flag syntax in order to set the argument for name to woman who code, and that would print out hello woman who code. So in order to try this out, the way you install Fire is with pip install Fire, and then the two things to remember are that you simply import Fire and you can call Fire on a function. Soon you'll see that you can call Fire not just on functions, but on any Python object, dict, class, you name it, in order to turn a wide range of things into command line interfaces. But first, why did I build Python Fire? The inspiration for Fire came from when I was working at Nest, and we were producing smoke detectors and thermostats, and we had a complex pipeline for ingesting data from all of these units in the field. We had the data that would pass through Amazon SQS and Kafka and Storm, and there were jobs orchestrated by Pentaho, and we wanted to test this series of distributed systems. So we wrote Python libraries to help with the testing. For example, we wrote a script that would put data in at the beginning of the pipeline, run a few steps of the pipeline, and then check the data was present at the end of the pipeline in the appropriate format. The same functions that were useful for creating these tests were also useful for writing scripts to operate on the system, and were useful for the operators who maintained the system in production. So we wrote a Python tool that would take the functions useful for testing and convert them into a command line interface that could be used by the operators. And so this was the inspiration for Fire. Fire is a more general version of this tool that works on absolutely any Python function or any Python object. And so dealing with pipelines such as this one is still a popular reason for using Fire today. All right, so I've said that you can call Fire not just on functions, but on any Python object. Let me show you how you can use Fire to create a command line interface that has more than one command. If you have a class calculator with two methods, add and multiply, then if you call Fire on the calculator class, the tool that you get as a result has two commands, add and multiply. At the command line, you can run calc add 1, 2, and that will print out 3. It passes 1 for x and 2 for y to the add method. And similarly, you can use multiply from the command line. So what does calling Fire actually do? First, I'll tell you the algorithm that Fire is using, and then we'll run through an example using the calculator class so you can see it in action. So Fire consumes arguments from the command line, and at every point during its execution, it maintains a current component. The current component starts as whatever you pass to Fire. So for example, the calculator class. And then Fire uses the arguments that it consumes to take one of these actions, depending on what the component is. If the component is a class, it will instantiate it. If it's a function, it will call it. If it's an object, it will get a member or property of that object. And the result of taking this action gives you a new component. And then this process repeats until all the arguments are consumed and there is no action left to take. And when this is finished, the resulting component is serialized in a human readable way and printed. So let's look at an example of this. What happens when we call Fire on the calculator class? If at the command line we've written calc add 1, 2, let's step through exactly what the algorithm does. So the initial component is the calculator class. Since that's a class, we're going to take action A, and the result of the first step of fire is an instantiated calculator object. Then we go back to the top, and since our current component is an object, we're going to take action C, get a member or property, and we're going to consume the add argument in order to do so. So the result of action C is the add method on the calculator object. Since that's a function, the next thing we're going to do is we're going to take action B, calling that function. To do so requires the two arguments 1 and 2, and the result of add 1 and 2 is 3. So now the current component is 3. There are no arguments left to consume. We can't instantiate the number 3. We can't call it, and there's no argument telling us what member or property of the number 3 to get. So we're done. And so the number 3 is serialized in a human readable way, which is to say it just prints out the number 3. So this is a highly general algorithm, and this is the reason that Fire works with any Python class, object, function, module, or dictionary, or any other Python component you might have. So I've shown you how you can use Fire to create a command line interface with multiple commands. Now that you know exactly how Fire works under the hood, you can think of a second way to create a CLI with multiple commands. We can pass a dictionary where the keys are the different commands that we want to have in our command line tool. And so passing this dictionary gives us a CLI that's very similar to the one we made using a class in the previous example. Another thing you can do with Fire is you can call it passing no arguments at all. If you call Fire passing no component, then Fire takes all of the locals and globals that are in scope at the time when you call Fire and uses a dictionary containing all of those as the initial component. So in this example, we've called Fire with no arguments, and so we get the add and multiply commands in the tool, but we also end up with the Fire module itself being exposed as part of the tool. Calling Fire with no arguments can be really useful if you want to quickly create a CLI for like an internal tool, but it's probably going to expose things that you wouldn't necessarily want to expose to an end user. And so that makes it more suited for an internal tool or for debugging purposes. So just to recap, you can call Fire on classes, dictionaries, or you can call it with no arguments at all, and that will use all the locals and globals currently in scope. Since the Fire's algorithm is so general, you can also use it to create CLIs that have hierarchies of commands. So in this example, we created a class tools that contains calculator as an attribute. And so this means that we can use the calculator group of commands, which includes add and multiply, as well as anything that's exposed through this widget class here. So that concludes the first workflow that Python Fire enables, which is creating command line interfaces. So why did we call Python Fire Fire? Now that you know how Fire works, you can see that the reason is when you call Fire, it's firing off your command. Contrast this with other command line interface libraries like argparse. When you call parse on argparse, it merely parses the arguments passed at the command line, but it doesn't execute the code that those arguments indicate. With Fire, it both does the parsing of the arguments and it does the execution of the command. So your call to fire.fire won't return until after the command has finished executing. If you have questions about anything so far, or if you have questions on the line, of course, feel free to drop them in the Q&A in Zoom. We're now going to turn to the second workflow that Python Fire enables, which is the Python Fire is a great tool just for your everyday debugging and development of Python code. And the first reason for this you've already seen, which is that you can always, at the end of any program, call fire.fire with no arguments. So if you have a complex program, you simply add the call to fire.fire at the end, and then you can start using the program from the command line. There's a second reason that Fire is so useful as a debugging and development tool, and that's that every Fire CLI comes with an interactive mode. The way you use this is you run your Fire command with the -- interactive flag added. And when you do that, Fire will start a Python REPL pre-instantiated with useful imports and objects relevant to your code, so that you can immediately start using your code in the REPL without having to go through any boilerplate, such as in importing libraries or instantiating the object that you want to work with. You can also pass -i for short instead of -- interactive. But one thing you'll notice is that there's this separating -- in between the flag and the Fire command. And so in the next slide, I'll tell you why that is. When the REPL starts up, it shows you all of the different objects that it's made available, and that will include both the initial component passed to Fire, as well as the result of executing the Fire command. It also includes information about the Fire execution and any imports that you had in your program. All right, so every Fire CLI comes with these 6 flags. And when you use these flags, it's important that you separate the flag for the Fire library from any elements of the Fire command using this isolated double hyphen. And the reason that Fire requires that is to prevent confusing these flags from arguments to the code that you've turned into a CLI. The one exception to that is the help flag, which you don't need the isolated -- for. To get help from a Fire CLI, you can simply add -- help or just -h for short, and that will show you help for the CLI, and the help comes pre-populated using information extracted from your Python program, including parsing the doc strings for descriptions and arguments, and those get used to populate the man page style help. So I've described interactive mode, which is very useful for debugging and development. The other command flags that come with Fire CLIs are you can set a separator. The default separator is hyphen, and this is useful if you want to chain Fire commands together. And later in the talk, I'll show you an example where we use a separator to chain a few different commands together. Fire CLIs can also take the completion flag, which will generate a tab completion script for your CLI. We support both bash and Zeesh, I believe, for the completion scripts. If you pass --trace to a Fire command, then in addition to the output of the command, Fire will tell you the step-by-step process that it took during the execution of the command. So similar to how we stepped through the process of executing add 1 and 2 in the calculator command, you'll see something similar if you run a command with --trace, and that can be useful for debugging. And finally, the verbose flag will show members that otherwise would have been hidden. A member might be hidden because it starts with an underscore, for example. But when you use verbose, those will all become visible. All right, so we've seen that Fire is really useful as a debugging and development tool. One point about this that I want to emphasize is that when you write a CLI with Fire, your CLI will always stay in sync with your program without you needing to make changes to your CLI code. With other CLI libraries, if you added a new function to your code or a new argument to one of your functions, you would have to update the CLI code in order to handle these new changes. But with Fire, since it's creating the CLI automatically on the fly, you don't have to touch the CLI code. It always stays up to date. And then you've seen how interactive mode can be useful as a debugging and development tool. So that wraps up the second workflow that Python Fire enables, which is debugging and development. So what are people doing with Fire out in the real world? The most common use is for developing internal tools. People are making all sorts of tools to make their development lives easier. It's also quite popular with data scientists. OkCupid uses Python Fire to create tools for accessing and analyzing data. And it's also popular in the London data science community, I understand. One person who I've corresponded with uses Fire in order to extract data from aftermarket engines. So they create CLIs for that. And then about 10% of the use cases, of the uses of Fire on GitHub are for machine learning projects, including the GPT code base. And there's a project AI Dungeon that makes use of Fire as well. There are also hundreds of uses within Google, although GFlags, another CLI library, remains the Google standard for creating command line interfaces. So let's turn now to the third and final workflow that Python Fire enables, which is exploring third-party projects. So you've already seen that you can call fire.fire on any Python component in order to turn it into a CLI. And this includes third-party modules. You don't need to be able to access the source code of something in order to call fire.fire on it. And new in the most recent release of Fire, you actually don't have to write source code at all in order to call Fire on something. You can do it from the command line with Python-n Fire. And I'll show you an example of both of these things for exploring and using the Python imaging library, PIL for short. So we're going to write a 3-line Python program. We're going to import the image class from the Python imaging library and call Fire on the image. And with just these 3 lines, we've created a tool kind of similar in functionality to ImageMagick. Now we're going to take this giraffe image and demonstrate what you can do with this. So we can now run at the command line. If we save this file as imagefire.py, imagefire.py, open the giraffe file, convert it to grayscale, resize it to be 100 by 100 pixels, and save the result as giraffeout.png. And if we run this command, the result will be a small grayscale giraffe. Using the new feature from the most recent release, we could also skip writing this file and just run python-m fire pil.image and then the rest of the command, and that would have the same result. So what are these separating hyphens doing in the command? These are the separators that I alluded to earlier, and now I'll tell you why they're useful. The open function on the image class accepts the file name as an argument, but it also accepts 3 or 4 more optional arguments. And so by passing this separator at the command line, we're saying that we don't want any more arguments to be passed to open. And so the rest of the command, starting with convert, will get applied to the result of the open command rather than being passed to the open command. So open giraffe.png returns an image object, which has this convert method. L here stands for luminance. And when you take the luminance channel of an image, that gives you just the grayscale data, but not the color data. Similar to open, the convert method accepts additional arguments, but we just want to pass this one argument, and so we include another separator. Convert returns an image. The same thing is going on here, where resize takes optional arguments. We don't want to pass them, so we use a separator. Resize returns yet another image, and it's on that final image that we call save. And we save the resulting image to giraffe.out.png. So that's how you can use a third-party module as a command line tool. In addition to allowing you to use it, it also is creating man page style documentation for these third-party modules using information such as the doc strings from the modules. We'll look briefly at a second example using the built-in calendar module from Python. So again, we've created this 3-line program that just calls fire on the built-in calendar module. And immediately that gives us a tool where we can start to see how the calendar module works, what are the different functions it contains, what are their arguments. And so, for example, we might run calendar 2020 in order to print out a calendar for the year 2020 at the command line. Fire also works with other third-party modules, so some that it might be useful with include the request module or Beautiful Soup for parsing HTML. So that concludes the third and final workflow. And I thought I would end just by briefly talking about my experience maintaining and releasing this as an open source project. So I released Python Fire on GitHub back in 2017, and it was really well received. I built Fire just to scratch my own itch from my work at Google and at Nest. But after releasing it, it's gotten quite popular. It has over 17,000 stars on GitHub, and it's had, and there are thousands of open source projects using it. It's had over 10 million installs from every country around the world. We've now had 40 different people contribute patches and work on the project. And it's really nice to see that the effort is appreciated and to have this fresh stream of ideas and excitement around the project. My favorite thing since releasing it is that someone has written a blog post about why Fire is a good tool for teaching Python, because it lets a beginner start writing Python without needing to worry about boilerplate. And so I'm hopeful that Fire is indeed helping people learn to program. If you want to learn more about Python Fire, there's a Python Fire guide at bit.ly/fireguide, as well as documentation and the source code on GitHub at google/pythonfire. And if you want to get started using it, all you have to do is pip install Fire. That wraps up the content of the talk. You've seen that you can use Fire for creating command line interfaces, but that it also serves as a useful tool for your everyday development and debugging of Python code. And you can also use it to explore things offered by third-party Python modules without even needing access to their source code. Thank you all for being here and for listening, and I'll now try to figure out how to find the Q&A and see if there are any questions. Thanks, everyone. Okay, it looks like there's no questions in the Zoom Q&A, but there is one in the chat. Are there any use cases of using this library in the data engineering space or data pipelines? Yeah, so there's two different ways that I've seen Python Fire used in these two spaces. So the first I alluded to earlier, where if you have a data pipeline consisting of maybe many different systems, then Fire can allow you to write functions for operating those different systems once and use those functions that you wrote both for writing scripts to operate the systems and for writing tests to make sure the systems keep working, and just for operating the systems manually directly from the command line. And so that's a common use case for Fire, and it can save a lot of boilerplate type code to use it in that way. And then the second data science-y way that I've seen Fire used is for data access and analysis. So rather than using it to manipulate the infrastructure used in data collection, people write Python code to enumerate data points from some data source. And they will also write functions that take arguments to filter the data to the specific points that you care about. And so if you take a program like this and call Fire, now you have a tool that allows you to efficiently look through the data at the command line. And since it's at the command line, you can combine it with other Unix tools like grep or sed or tr or whatever your favorite Unix tools for dealing with data are. You saw in the examples in the talk where the functions would return a value and then Fire would print out the value. Another thing that Fire supports is generators. So if you write a Python program with a function that yields values one after another, Fire will print them out as they're yielded. So if you have a particularly large data set, Fire will work with that as well. The next question is, does it work with Python 2.7? Yes, even though Python 2 has reached end of life, we have continued to make sure that Fire works with all Python programs, whether they're written in Python 2 or Python 3. If you're interested in contributing to Python Fire, the GitHub page is github.com/google/pythonfire. And there are a number of issues that are tagged with help wanted, and those are a great way to get involved. You can also reach out to me at any point. My email address is here in the lower left, and my Twitter handle is here in the lower right, dbeiber@google.com and @Bieber on Twitter. So feel free to say hi, and I'm happy to have a conversation there. Do we have any more questions? I see earlier someone asked if it's open source. Yes, it's all open source. All right, thanks so much, everyone. If more questions do come up, or if you'd like to talk, you know how to reach me, and it's been a pleasure.
Thank you so much, David. We do have a suggestion in Q&A that it would be great if we would have first good issue labels on GitHub for contributing.
Yes, that's an excellent idea. Yeah, we don't have those. The best issues to start with would be the ones that say help wanted.
Thank you so much, David, for your time. This was an amazing session, and I really like this library, and I'm looking forward to incorporate this with my machine learning projects.
Thanks so much.
Thank you so much, everyone, for joining. And feel free to reach out to David regarding any questions for Python Fire. Feel free to contribute, check out the library, use that in your projects, and feel free to join our community WWCode. So here is the Slack link, and you should be able to join the community from there. I'm dropping the link in the chat. Using this link, you'd be able to join our Slack. We offer support regarding any technical issues and projects, and we have sessions each week and month regarding multiple technologies and projects. So feel free to join our community and drop any questions if you have. And thank you so much, David, again. Thank you so much, everyone, for joining.